Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Today we will discuss three methods to solve the problem starting from O of n square to O of n log n, which will be the most optimal one. And we will also discuss an O of n root n solution, which is actually given in the editorial. Okay, so you can follow that. We will also discuss it. So this method is the one which you should mainly focus on because it is the most optimal one and it gives a general idea to solve these kinds of problems. So let's see what is the question. Fruits into baskets 3. So I hope you have already solved yesterday's problem, which is fruits into baskets 2. You are given two arrays of integers, fruits and baskets, each of length n, where fruits of I represent the quantity of the ith type of fruits, and basket j represent the capacity of the jth basket. And you must place the fruit in the leftmost available basket. So the capacity of the basket must be greater than the quantity of the fruit. Okay, so what can you do here? What it is happening basically? So in case if you have not understood the question only, so let me just quickly go through it. What does it mean? 354 and 425. So what you have to do is that this is your fruits and this is your baskets. You need to place fruits in baskets, so definitely the quantity of the capacity of the basket must be greater than the number of fruits. So you need to start from the left and find the largest basket which is just greater than the fruits of I. Okay, so let's say my current pointer of the fruits is now in this, and we need to find something in the basket which is greater than 4. So we find that that's 5. Okay, and we empty the whole basket. Okay, we empty the whole basket because the remaining I mean there is no remaining space after keeping 4 elements. Okay, you don't think that there is one space. You just cannot place any other fruit. Okay, so after this you find you go to the next element, you see 2, and you find the leftmost index which is just greater than 2. You see that that's 3. Okay, and so you can place 2 here. And when you go to 5, you see that you need to find the leftmost element which is greater than 5, greater than or equal to 5. Okay, but 5 is already been done. 5 has already been taken by 4, so that's 4, but this is not something which is greater than or equal to 5. Okay, so this fruit, this type of fruit will remain unplaced. Okay, this type of fruit will remain unplaced, and there are total of one type of fruit, which is number of types of fruits which remains unplaced is 1. Okay, so answer will be 1. So I hope you got how what does the question exactly once. Okay, so so you see the answer is 1 here. So I hope you can easily think of a brute force O of n square solution to this, which was the actual solution to yesterday's problem. So it basically means that you go through all the elements in F. Okay, so let's say you go through for F in fruits. Okay, so you go through all the elements in fruits, and you also go through all the elements in baskets. Okay, and what you can do is that you check that whether fruits is if fruits is less than equals to basket, it means that you can place that in the fruit, and then you empty the basket. Okay, then you just empty the basket, and if you do not find any basket where the fruit can be kept, if you do not find any such basket, then you just keep an answer. Then you can just keep an answer here. Okay, and you just increment the answer whenever you find. Okay, so whenever you find something, uh, when you find some condition violates, what is the condition is that you did not find any basket where the fruit can be kept, then that fruit is remained unplaced, and you need to count the number of unplaced fruits. So you just increment answer. So this is what the solution was to yesterday's problem. Okay, so because it is very related, so I'm just discussing the brute force solution also, so that things try to click on your mind. So this is fruits and baskets. I hope you understand this. I keep a flag which says that whether it is placed or not. Okay, so if I find a basket in which I can place the fruits, I empty the basket. Okay, and I place all the fruits in that. I make flag 0. It means that I have found something to be placed. If I did not find something to be placed, the flag will remain 1 and answer will be incremented, and we will just return answer. I hope this approach is very clear and simple to you. This is a simple brute force approach. Now I will try to explain you the method using segment tree. Now yesterday I had already told you that you should learn what is segment tree. Okay, some basic thing at least you should learn what is segment tree before watching this video. But I will try to explain in such a manner that even if you are a beginner, you will things will not go at least above your head. Okay, you will just at least get what is going on. Okay, so to get a better understanding, maybe you need to watch a much longer video, but I will try my best. Okay, I will try my best that even if you are not so comfortable with segment tree, or guys who are not so comfortable with segment tree, they also find the video very helpful. Okay, so let's see what is a segment tree first at first. Okay, okay, so the segment tree helps you to find the range queries. Okay, so what does the range queries means? It means that you have something, let's say you have an array 4 2 6 1 3 8, something like this. You have an array, and you are given queries where you need to find from L to R. So in first query, if I ask you what is the maximum number in this range, your answer is 6. Okay, but in a brute force manner, you might have to traverse this whole, almost this whole array. Okay, almost this whole range. Then I ask what is the maximum element from this to this. Then you might need to find this whole, traverse this whole sub array again. Okay, then you can give me your answer as 8. But you see that for every query, if I ask you q queries here, for every query you take an operation of O of n. Okay, so if I ask you n queries, okay, you will take O of n square. Okay, so that's what a brute force approach will work. But for segment tree, what happens? You answer every query in O of log n. Okay, so what do I mean by it? I mean to say that you can answer with this answer as 6 in log n time. Okay, in log n time. So you use some efficient data structure and you are able to answer it in log n time. So how if number of queries is n and each query takes log n time, so definitely the time complexity will be here n log n, and this comes out to be the most efficient time complexity for this solving these kinds of problems. Okay, now here we use something a little bit different from what is called a range query. If here we find using you, if you are given an array using segment tree, we will find that we are given an array and a value. I find the leftmost index. Okay, leftmost index, uh, which is, okay, whose value, okay, whose element is just greater than or equal to value. Okay, so I find the leftmost index. This is what I am exactly finding using my segment tree. The leftmost index whose element is greater than or equal to value. Okay, so I will use the type of segment tree. The building approach of segment tree will be exactly the same. Okay, so how exactly that works. So let's see how what exactly is a segment tree. So I have already drawn this for the benefit of you. So what does a segment tree store? So you see, it is a tree definitely, but it is an array which stores some values in its indices. Okay, now the value which it stores in this index. Okay, so if I tell you that what value it stored in its zero index, this zero represent the index number of the segment tree array. Okay, segment tree is nothing but an array at first. Okay, so the first element of the segment tree stores, let's say we need to find the maximum. Okay, so here we were finding the maximum values. Okay, we could have found minimum also, we could have found some addition also, or also anything. Okay, but here we are focusing only on maximum values. Okay, that is required for this problem. So each element of this segment tree stores the maximum in this range. So the first element stored what is the maximum value from 0 to 6. Okay, from 0 index to 6 index, what is the maximum value it will store. Okay, and the first also this index number 1 will store what is the maximum value from 0 to 3. This index number 2 will store what is the maximum value from 0 to 4 to 6. Okay, and again similarly it will go on till it will reach the leaf nodes, and leaf nodes will store what is the maximum element in from 0 to 0. It means that it's 2 only. Okay, you see what is the maximum element from 0 to 0, it's 2. What's the maximum element from 4 to 4? It's 4. Okay, so it is giving the whole array only. So if you just try to write the values of what it will return exactly, it will look something like this. This is 9, this is 7. Okay, now I will take the max of this and this left subtree and right subtree. I will take the max value, so that will give me 4 here. Okay, so what is the value it stores in index 0 to 4? What is the maximum value among index 0 to 4? It will be 4. Okay, so among 1 and 8, the maximum is 8. Okay, it gives me 1, it gives me 8. Okay, now from among 3 and 9, which is the maximum, is 9. Among this gives me 7 only. Okay, now among 4 and 8, which is the maximum, which is 8. Okay, among 9 and 7, which is the maximum, which is 9. Okay, among 8 and 9, which is the maximum, which is 9. So you go to any index now. It since it is a binary tree, you see, segment tree is nothing but a binary tree. So you see, traversing through the tree of the height of the size of the height, it will be log n. Okay, so you know the binary tree is of size log n. So what will happen is that uh, since it is a binary tree, you can traverse once you build the whole tree. Once you build the whole tree in this manner, so let's say, which gives the maximum value. Now it you can answer what is the maximum value among 0 to 3. You can just go to this node and answer me. Okay, but what exactly is required in this problem? Okay, so there are also few before I go to code the solution, I also this much intuition I hope you understand about binary tree, but want you to notice some more facts. Okay, so some more facts about this segment tree. So I hope you get how we calculate the values inside the segment tree. Now, uh, I want you to notice more facts. Okay, so if I want to tell that what are my child, if my node is I. Okay, so if I am in node I. Okay, who are my child? Can I say that if I am in ith index, my child will be nothing but 2i plus 1 and 2i plus 2. So this is a typical observation in any binary tree, in fact. Okay, so 2i plus 2. So that's what I wanted to say you. Let's say you have 4. What are its child? If I want to say that, then 2i 4, 2 into 4 plus 1 is 9. 2 into 4 plus 1 is 10. Plus 2 is 10. Okay, so 9 and 10 are the child of 4. So if you want to find the child of a node numbered I, you need to go to 2i plus 1 and 2i plus 2. So that's how you will find the ith node. Okay, and while returning, I hope you can easily understand that if I am having this segment tree, I can just do segment tree. How do I return it? As I was telling, that while returning from the left and right, I will just take the maximum among both of them. So from in the ith index, I can just store it something like this. Tell me if you understand this segment tree of 2i plus 2. And if I try to store the maximum value in segment tree of I. Okay, so when I am in the ith node, when I am in this ith node, I am storing what is in my 2i plus 1 and what is in my 2i plus 2. So it means that I'm from both of my child, I'm storing the maximum value. So I hope you get this easily. I hope you get this intuition easily. So that's all about the theory about segment trees of how they work, and we will understand that how exactly it helps us to find the lowest number, which is just the leftmost index, which is just greater than a particular val in or log n time also. Okay, so you can do that easily. So let's try to build the segment tree at first. So another thing I need to tell you that about segment trees is that uh, what is the number of nodes that which I will initialize it to. So if you notice, try to notice here. Okay, if you try to notice here. Yeah, just a second. It is yeah. If you try to notice here, uh, for an index, okay, for an array of length 7. Okay, this is 7 length array. How many number of nodes are there? So you see here are n nodes. There are n by 2 nodes. So for an index of 8, let's say, which is a power of 2, the number of nodes will be 8 plus 4 plus 2 plus 1. So that's 16. Okay, that's 15. So, which is just less than 16. So, number of nodes will be nothing but 2n minus 1. But when I am in the ith node, I also try to find something which is 2i plus 1 and 2i plus 2. So, it is always safe to build a segment tree of size 4n. Okay, so it's always safe to build a segment tree of size 4n. So, I hope if you are not able to understand, you can just search this in the Google, that why segment tree has only 4n number of nodes. Okay. So I try to explain here in a very simple manner. So I will write a void function which will build the segment tree. Okay, so what are the values it will take? At first, I will definitely have a segment tree array vector. Okay, uh, I have this. I find what is n. I just find what is n, and I will just resize it. I will just write resize 4 into n and minus 1. Okay. And I will build the segment tree, which I just told you. Okay. So what parameters I will take? I will tell that the starting point should definitely be, first of all, I need to have the baskets, right? Because these are the, from the baskets only, am copying these values into the segment tree. Okay. So baskets is my master array. Okay, so this baskets I just take it and I just make it 0 n minus 1. This just, what are these arguments? These arguments are nothing but my array, which from which I'm trying to convert into a segment tree. The first element, and I mean the starting point. Okay, and also the L to R. Okay, L to R means within what range I need to build this. Okay, so I will build it recursively. And so let's say you will understand as things goes on. So as this is baskets, this is I, this is L, this is R. Okay, so now what will happen is that I will try to build this segment tree. So what I will do is that definitely, as I told you, I will write something like segment tree of I is nothing but maximum among segment tree of 2i plus 1 and 2i plus 2. Okay, that this thing is, I hope is clear to you. From the left side and the right side, I am taking the value which is the maximum. Okay, and in the case where L is equals to R, meaning that when I have reached the leaf node, what I can do is that I can store my value in the segment tree. Okay, so I can just go to the ith index in the segment tree and store the value which is in the baskets. Okay, so which is in the baskets of L, let's say, because L and R both are same. We can just do this. Okay, and now we need to call this function recursively. I mean, these elements won't get automatically filled up. Initially, it's just minus 1, right? So in order to fill them up, definitely need to call them recursively. Now, if you note that, in what way do I split this? Okay, so when I tell that from 0 to 6, it goes from 0 to 3 and 4 to 6. So it goes from this and this. So if you see, I have split it. If its size is, let's say, n is 7, so 7 by 2 is nothing but 3. So 0 to 3 I take. Okay, and the remaining. So if I have some mid which is n by 2, then I go from 0 to n by 2 and then n by 2 plus 1 to R. Okay, so you see, uh, if I have something like 0 to n by 2. So what do I mean to say is that I will have a mid value, integer mid value, which is nothing but n by 2. Okay, L plus R by 2. I will just have this L plus R by 2, and then I will search in both the left subtree and the right subtree of the segment tree. So I will just go through these baskets, and my left subtree will be nothing but 2 into I plus 1, and the mid value, it will search from first the left value till the mid. Okay, and definitely it will also search something like in the right child, it will the right child, and from mid plus 1 to R. Okay, from mid plus 1 to R. So I hope you understand that how it calls recursively. So it will be 2i plus 2. So yeah, that's all in building the segment tree. So you have the segment tree in front of you right now, and you want to query the segment tree right now. Okay, so what will be the result of the query? So every time, what you can do, you can have something to start with. Okay, and you can have an L and R value, definitely. and you can have the value which you need to search. Okay, so what I am doing is that I am finding the a value. In an array. I am finding the leftmost value. I am finding the leftmost value which is just greater than or equals to this val. Okay, so this is just greater than or equals to this val. Okay, so what can I do? What can I do? I know that each node of the segment tree stores the maximum value in the range, in its complete range. In each node of the segment tree stores the maximum value. So what can I do? So I can first of all I can write this. Okay, so this let me say that this will give me a bool value, and it will query something. Okay, so for all, it will first iterate through all the fruits. Okay, so for auto, let's say you go through all the fruits and you need to find the fruit. You need to find the basket which can be placed in the fruit. I mean the fruit which can be placed in this particular basket. So you can query the segment tree. You can query the segment tree to be something like 0, 0, and n minus 1. So every time you're telling it you should go to 0 to n minus 1, and you should find x. Okay, and if you could not find something, if it is false, then you increment your answer plus plus. Okay, then this fruit cannot be placed, and then I will return the answer. Okay, so I will increment the answer then only if this fruit cannot be placed. Okay, otherwise, if it can be placed, it's very good. It's well and good. Okay, so now you see that what if you find that if the segment tree. Okay, so if the starting of the segment tree, it means that if let me keep it I. Okay, let me keep it I. So if the index of the segment tree is having a value, it means that it is having the maximum value in the range of L and R. So if that maximum value is less than this value, it means that there is no point of going into the depth of the segment tree. I will just return false. Okay, so I will just simply return false if my ith value is only less than the value which I want to find. Now if it has come to this, it means that it has a value, it has a particular value. And so I will now tell that if you are in the node which is L equals to R, what you can do, you can just return your answer. Your answer will be true because you have found something. You have not found means you have found something, and you also must remember to empty that element in the segment tree. That is, you must initialize that value to -1, because I am doing max, right? I am taking the max value, and if you just take -1, it will never appear in your answer. Okay, so to make sure that it never appears again in my answer, since I have already taken up this index, so then I just return true. Okay, so you already know that you reach L equals to R means you reach the node of the segment tree. You reach the leaf node, and leaf node is nothing but the element. Okay, so leaf node is the particular element because it gives a singular range. So it gives a singular range 0 to 0, 1 to 1, or it gives a particular value only. So whenever you see that you have reached the leaf node, and it means and that it has a particular value also, then you can just return true. Otherwise what you could have done is you could have gone to the left subtree and the right subtree. So otherwise you just have a mid value L to R, and you also have let's say a bool value placed. Okay, which is initially false. And now if you see that, if you greedily select, so you need the leftmost index. Okay, you need the leftmost index which is just greater. So greedily I will just pick the leftmost index first. So I subtree. So greedily if you go, you will be going to the left subtree and checking if something in this range is greater than me. So I will just do something like segment tree of 2i plus 1. So this is my left subtree. If the value here is actually greater than or equals to val. Okay, so it means that in my particular, I can place this fruit, then I will do something like return. Okay, so then I will just do something like return query. So it means that there is something in the left index. Okay, so there is something in the left index. So I should just place it. I should just place it in the placed value. and I will just query it. Okay, so what will be my query look like? So it will tell me that go to the left index because there is some possibility of answer, and you go from L to mid and definitely this val. Okay, and else what you can do? Else you can just do placed equals to query 2i plus 2. It means if there is not in the left subtree, definitely you need to go to the right one, and from mid to R you can just search the value. Okay, and you can just return placed. You are just changing the place bool value, you can just return this placed. Okay, so I guess that will be all. I guess that should be all for solving this problem. And you see, the code is not that much big. The code is not at all that much big. I hope I was able to. Definitely, if you're new to segmentary, definitely this will be little bit difficult to digest. But I hope I was able to make this clear. So if I am getting a wrong answer, so let's see what is my error in the code exactly. So as you can see in the query, I just forgot to write this thing. Okay, so uh, this thing needs to be even after placing it, you are altering some of the values of the segment tree. So definitely you need to modify the segment tree also recursively. So don't forget to do that. Just don't forget to do that also in query and build both of them. This thing must be there because from the left subtree and the right subtree, you are picking up something which is maximum. So I hope you understood it. Let's try to submit it and check. You see, we have a pretty good runtime complexity. So when I submitted it earlier, it was giving me 90% beats. It is giving 60% now. So but whatever be the case, I hope you understand this. This is a simple O n log n solution. If you are doing it for the first time, definitely it will be difficult for you. But try your best to understand. I have tried my best to explain it in a single video of what is segmentary, how you should solve this problem. But you see, there is also a very interesting solution which is given in the editorial. So it is of the order of n root n, which is not so optimal. That is why I'm not just coding it out, but I will tell you what is the intuition behind this because ideas are always helpful. Okay, so you should keep ideas. So what it is doing is that it is breaking the array into root values. So what does it mean? So you have a very long array with you. Okay, so you have a very long array with you, and you need to find the leftmost index which has a value just greater than. Okay, so you need to find some array of leftmost index which is just greater than or equals to. So what you can do, since you are having a very large value, let's say n, you divide this n into root n number of blocks. Okay, so let's say this is one block, this is one block, this is one block. Now there are root n such blocks, and each block definitely has a size of root n also, because root n into root n will also only give you n. So you see what you do, you divide the array into root n blocks. So and then you map the blocks. Okay, so you will now know that as you are, let's say you are going through the fruits array for f in fruits. So when you take this f and go through this element, you will see that my f fruit is my f fruits lying in this particular block. Okay, so how we will choose that block? You store that block's maximum value. Okay, so if the max value of that block is, let's say, less than or equals to my fruit, then definitely I can place the fruit. Otherwise, I cannot place the fruit. So let's say you are iterating now block wise. You see this block, you go to this block. Let's use a different color. Let's say you this first block, this second blocks. Let's say you go through some ith block and find that the maximum value of this ith block, okay, is greater than my f. So it is true that I can place this element. Now when you go to this ith block, okay, this block has root n number of elements. You just traverse each of those elements and find which is the leftmost element. Okay, you just traverse in the ith block, you just go through all the elements and just find whichever is the one that gives me. So that's what it is doing. You can just go through the solution also. For each fruit, we scan this block by block. If the maximum capacity in the basket in the current block is less than the fruit's capacity, then we skip this block. And if we find the maximum value is greater than or equal to fruit, we scan that particular board block. So what is the time complexity which you are using in this code is that for every you go through all the blocks. Okay, every block you can have an n elements, but you have array of size n. So for building the blocks you definitely need n time complexity. So n root n is what you will be using this. So you can just go through the approach. Okay, you can just go through the approach and look into it once. Okay, so yeah, that's all for this video, I guess.